Hello, my name is Gunnar Fry, and I will be presenting my research on the issues with building low carbon emission structures. Climate change is an ever important issue in today's society. The world continues to grow with more people, and that requires us building more buildings and home and residential structures. Every industry has been affected by the climate change in one way or another, which also includes the construction industry. There's been multiple innovations and changes in the way that we go about building structures and the materials that we use, and there will be multiple changes in the future to decrease the amount of carbon that is being released. Embodied carbon is one issue that we try and decrease to decrease the amount of carbon being released. Embodied carbon is the amount of carbon that is released through a material's entire lifespan, including its extraction, production, time in use, and eventually its disposal or recycling. It is important because it doesn't just look at what material adds to the building performance, but it solely looks at the material and what carbon it adds to the overall carbon footprint of a building. Steel has the highest amount of embodied carbon, which is right behind, and then concrete is directly behind that. These are two common materials used in commercial construction, so this shows the innovations that we can make in this portion of construction. Less is more. Decreasing the amount of materials that we are using in building a building will decrease the amount of carbon that we are releasing. It's important to talk to engineers and architects in the early stages of a building because they can look at the materials that have the highest amount of embodied carbon and try and use the least amount of those. Optimizing the structural integrity of these materials is very important. It will allow us to use less of these materials. It's also important to make sure that we are building a very stable structure. Thermal bridging is another important issue that we have to look at. Thermal bridging is when the temperature outside is warmer or cooler than the temperature inside of a building. What can happen is if a structural member is connected to the inside and outside of an external wall, the heat will move from the structural member from the outside to the inside, which causes it to increase the heating or cooling loads of a building. And whether we are using propane, natural gas, or electricity to heat or cool a building, those all include releasing carbon in their extraction and use. Building envelope is another issue that we look at. The building envelope is the space that is conditioned, which is covered by the structure. Efficient building envelopes can decrease the heating and cooling loads by up to 35%, which is a big difference, and will decrease the amount of carbon released by a lot. Insulation is another important issue that we look at in a building envelope. Using a continuous insulation that goes around the entire edge of the outside of the structure with no members going through the insulation allows for a tighter sealed building envelope. Material properties is another important issue that we look at. Using materials that release the least amount of carbon during their life cycle and their time and use in a building is very important. OSB is a good thing to use because they create it using younger trees, which have less sequestered carbon inside of them. And using insulation that has no hydrochlorofluorocarbons in them is very beneficial because these are very harmful ozone depleting gases. Polyester is a better type of insulation because it has no ozone depleting gases inside of it. These are all issues that we are trying to solve, and they all have their individual solutions but there is no one solution to all of these issues. Structurally insulated panels, or SIPs, are something that are used now in the construction industry, but not very common. They are completely pre-assembled for a building, so there's no assembly of them on site. They are sent in panels, and then they are constructed and put together on site. I am proposing a structurally insulated panel that is similar to a SIP, but has many differences. In the panel that I am proposing, it uses angle brackets to connect the panels together, instead of where SIPs use actual studs and top and bottom plates to connect the panels together, which causes thermal bridging. This would be using brackets, which would not allow for thermal bridging because they would be placed on the inside of the panel, which means that there would be insulation in between the outside and the actual brackets. They would then be screwed in through the inside, through the OSB and into the brackets. They would be covered in a vapor and moisture barrier, which creates a good air-sealed building envelope, which would decrease the heating and cooling loads. For commercial use, the OSB would be replaced by rigid steel, thin sheets of rigid steel, which would allow for no thermal bridging, a decrease in use of steel, which would decrease the amount of embodied carbon in the building. And they would also be very structurally strong. This would decrease the amount of concrete needed, which also has a lot of embodied carbon, because there would be no CMU blocks used in walls, which are commonly used in commercial construction. These types of panels would be able to be used in wall, roof, and floor systems. And it does not need extra wood members like an original SIP panel, which they use headers, top and bottom plates, and studs. There would be a large price difference in them because they are pre-assembled, but there's a large return on investment because the heating and cooling loads of the building would be decreased, and it would be decreasing the amount of carbon released into the atmosphere. Thank you.